Hello, I review my semiconductor fabrication technology. First, local oxidation of silicon. This process is doing isolation by making oxidation layer.
로커스 풀네임이 뭐예요?
Locus, local oxidation of silicon, called locus. Standard process suffer from significant vertigo, so today we do not use this process. So nowadays we use STI, called shallow trench isolation, and DTI, deep trench isolation. This process has advantage by device cutting down, but this process has a difficult for making anisotropic etching, and thermal oxidation, thermal SiO2 is amorphous using for gate dielectric, and device isolation for locus, and STI shallow trench isolation, and ILD interlayer dielectric. And this thermal oxidation has two categories: wet and dry oxidation. Thermal oxidation has a excellent electrical insulation. This means has a lot of resistivity and high breakdown electric field. These stable and reproductive Si and SiO2, and conformal oxide grows on Si surface, and SiO2 is a good diffusion mask for dopants and very good etching selectivity between Si and SiO2. And modeling oxidation, thickness change the rate of oxide layer with time. We have to study this sentence. Alright. Okay. Now doping. Okay. Doping silicon has two categories: diffusion and ion implantation. Diffusion is the spread of particles through random motion from regions of higher concentration to regions of lower concentration. And vapor exposed to dopants is heat. And ion implantation, bombarding the substrate with ions accelerate to high velocity, just hit the surface. Step 1, pre-deposition. Step 2, drive in. Step 1, pre-deposition is we paint the material by pre-step. And drive in is the dopants are driven deeper into the vapor without further introduction of dopant atoms. Alright, and the summer budget. The process step using the high temperature is dominant, and annealing is the process by baking as the heat. This process is for diffusion in doping process, and we just activate dopants after doping. For crystalline, the impact for curing, and RTP rapid thermal process with base ramp heating and short in duration, processing each vapor in several minutes and shortening time, a trade-off made in temperature and process uniformity, temperature measurement, control and vapor stress, and diffusion process cannot reach shallow junction and heavy doping at the same time. And okay, now last, the film deposition. First, separate in CBD and PBD. Chemical vapor deposition for CBD is the process by chemically reactive materials at the substrate surface, and PBD, physical vapor deposition, fillings formed by physical process of atom transport to the substrate in the gas phase. Growth mode, 2D layer by layer growth, 3D island growth and mixed growth, and filling crystallinity, epi process, no grain boundaries, require high temperature and slow grade, and polycrystalline, loss of grain boundary, and amorphous, no crystalline structure. As the step coverage, we have to take a lot of care in this process, and step coverage is how well the film covers topography.
Damn.
The CBD system, APCBD, PCBD, LPCBD, APCBD, best step coverage, other chemical reaction effective, PCBD, toxic byproducts, high cost of equipment, and LPCBD, slow process and high temperature process, and ALD, atomic layer deposition, built layer by layer. We can deposit any material by using precursor, 6-step vapor and precursor pulse and pulse and precursor pulse and legend and just cycle this process. Okay, thank you very much. Whew.